of rocks. And I always like to make that joke that rocks rock, because they totally do. Who here has a rock collection? If you have a rock collection, raise your hand. Okay, I have so many rock collections, I have to keep one of them in my car. I have that many rocks in my life. I put some of my favorite pictures up of different rocks that I've maybe seen in the world, or maybe I've just seen in pictures. I gotta show you guys this one just because I love it so much. What is this right here?
That's a person.
It's a person. What are these gigantic things in this cave? What are they?
Crystal.
Yeah, they're crystals. They're selenite crystals that took over 360,000 years to form underground in a cave in Mexico. That's just one of the examples of the amazing rocks that exist in this world. Now, my question for you is, why are there rocks as different as like a giant selenite crystal, or maybe a little nugget of gold, or maybe the sandstone that's found in the southwestern part of the United States? Why are there so many, like, how does this happen? How are these different rocks so different from one another? Yeah. Minerals. You're absolutely correct. So it's what they're made of, but also how they're formed. Can anybody think back to years past? You may have studied the 3 different types of rocks. Of all the rocks in the world, they can be broken down into 3 categories, depending on how they were formed over time. Can anybody think of those 3 categories of rocks?
Rocks, minerals, and crystals.
Ooh, you are so on the right track. One type, you may have learned this years ago, or maybe you'll learn it in the future, igneous rocks. We have a heck of a lot of these in Oregon because they come from volcanoes. That's how they're formed. Yeah, that's how they're formed, from lava. We also have sedimentary rocks in the world. Sedimentary rocks are formed usually in the deep, deep, deep ocean. They're made of little pieces of sediment, also known as sand. And all that pressure of all that water pushing down can squish sand together over time and make a sedimentary rock. It can even be made deep underground as well, but it's usually made in the bottom of the ocean. And then finally, we have metamorphic rock. Metamorphic rock is really interesting. It has to do with the tectonic plates, those rock plates that are deep underneath the surface of the earth that cover the world like a 3-dimensional puzzle. And when those tectonic plates scrape together, you might feel an earthquake. When a crack forms in a tectonic plate, we might have a volcano. So metamorphic rocks are made from the pressure and friction that can be caused by tectonic plates rubbing together. Now, we're not going to go deep into these 3 types of rocks today, but I just wanted to give you kind of an idea of all of the rocks in the world. They can fall into one of those 3 categories, okay? So the question is, what are we going to do for our lesson today? We're not just going to talk about rocks, but we're going to do an experiment on rocks. Now, in order to do a science experiment, if I said to you right now, do a science experiment this second, would you be missing some things?
Yes.
You guys need the way to do it, right? You need to understand the scientific method. As a scientist, how am I going to do this? Sonia's going to talk to you guys about what is this scientific method. What does that word method mean? She's going to teach you the scientific method according to ECO. And then we're going to use that method to do some science experiments today. Are you ready?
Yeah.
Okay.
Y'all ready for this? All right, cool, you guys. So, how many of you guys have done the science experiment in class? Raise your hand. This morning. Yeah, that's awesome. So, we're going to use another acronym to help us figure out how to do the scientific method. So, and we're actually going to use another acronym, like how ECO is an acronym. We're going to use another acronym to help us remember it. So I'm going to write it out. Okay, who wants to read that? You can all read it out loud. 3, 2, 1. Okay. Can you say it like you mean it? Okay. So, each of these letters stand for something in the scientific method. Now, let's think back to your experiment that you did this morning. What was the first thing you guys did? Observe. You made some observations, exactly. So the O in OPEC stands for observations. And what can you guys use to help you make observations? What do you use?
Hypothesis?
We're not quite there yet, but what are some things that you guys can use that you maybe have on your body that you can use to make these observations to help you come up with a hypothesis? Yeah, what do you think?
Hands.
What's that? You say your hands? Yeah, you can use your hands, exactly. So you can use your sense of touch to make observations. What are some other things that you can use? Yeah.
Head.
Your head, yeah, you can think about things, absolutely. What do you think? Your eyes, your sense of sight. So, yeah.
Nose.
Your nose, your sense of smell, right? We're on a roll now. What do you think?
Mouth.
Your taste. So unfortunately in eco-science, we are not going to be tasting scientists because the things that we bring would not be very delicious and it would not be very good for your body. So you guys can be tasting scientists at least 3 times a day. What do you think? Maybe breakfast, lunch, and dinner, you could be tasting scientists? But in eco, we're not going to be a tasting scientist, but that is definitely a really good way to make an observation. What's the last one?
Smell. Well, actually, as a little question.
What if like you're studying if you're studying fruits, then you can absolutely be a tasting scientist. Yeah. So our last, I think we talked about our sense of hearing, sight, touch, tasting, and then smell. So we can use our 5 senses to come up with our observations. Now, after our observations, you might have a question that you come up with. Maybe you say, I wonder why this is happening. So that can be your question, and after our question, you would set it. You come up with your, starts with an H, hypothesis. Yeah. So following your question, you have your hypothesis. So your hypothesis is, does anybody know what a hypothesis is? You want to tell me what it is? Yeah.
It means to like have a
Yeah, it's an estimate, or it's potentially an educated guess about what you think is going to happen, right? Educated guess. Okay, so after you come up with your hypothesis and you have an educated guess about what is going to happen, what do you actually get to do next? Yeah.
You get to test it.
Yeah, test it. And what is that called? Scientists are really famous for conducting these crazy things called
Experiments.
experiments. Yeah, which is what we're going to do today. Experiments. So there's a couple of things that you need to do before you actually start the experiment. So if I were just like, all right, scientists, go ahead and do your experiment, what would you be missing?
Literally everything.
Everything. You'd be literally missing everything. So you wouldn't know what to do. You wouldn't have the things to do it with. So you might need materials, right? So you might need, today we're gonna do some experiments on rocks. So you're gonna need a box of rocks and some other things to help you conduct the experiments. And you're also going to need a procedure. Does anybody know what the word procedure means? Yeah, what does it mean?
It's basically the instructions you followed to have this done, or
Yeah, exactly. It's a set of directions that you can follow to help you come up with this experiment. So after you conduct your experiment, you've figured out how your hypothesis works. What do you come up with? It starts with the C. So kind of the sort of end of the experiment. You have done your experiment and you have a kind of end of it. Conclusion, exactly. So you come up with a conclusion. It's sort of a summary of your findings. Maybe you've concluded that your hypothesis was actually correct, and what you thought what your educated guess was is actually happening. Or you found out that your hypothesis was wrong, which is just as informative as if your hypothesis was correct, because you learned something new. And the last thing you guys will gain at the end of the day, it starts with a K. Any guesses? Kindness? Not quite. You could be kinder though. Knowledge, exactly. And so these are the things that we are going to go through today to help us conduct our experiment.
Okay, so ladies and gentlemen, thank you, Sonia. That was fabulous. So now thumbs up if you understand OHEC. All right, so what's the first thing we need to do, scientists? We need to make some observations. Okay, so this is what you're going to use to make your observations. I'm going to make sure I have everybody's attention up here so we know the next step. This is a box of rocks, one of my favorite things. You will notice in this box of rocks that you have rocks 1, 2, 3, 4, 5, and again 1, 2, 3, 4, 5. That's because folks are going to be working in pairs. So one pair will get to use this row, one pair will get to use this row. You will also notice that it is important that if you take a rock out to make an observation, that it goes back into the same slot it came from. If you forgot which one goes where, there's a little reminder right there. So in order to make our observations, we're going to use our 5 senses, with the exception of taste, right? Okay.
I want to lick it.
So for example, what you guys are going to do is you're going to be making observations about these rocks. You're also going to be recording those observations on this rock property investigation sheet. How many rock slots are listed on the sheet? 5. How many rocks do you have? 5. Okay, so what you're going to do is you're going to start with your first rock maybe, or you can start with your 4th or 5th rock. It doesn't really matter, right, where you begin as long as you do all of them. Let's say rock number 1. Can somebody share an observation they noticed with their eyes about this rock? What do you notice? It's shiny. So what can I write on next to rock number 1? What can I write? Shiny. So I'm going to ask you guys not to write complete sentences today because it takes too much time and I want to have more time for our science experiment, okay? So you could write shiny. What else could you write about this rock? What do you think? Smooth. Nice. So you could write shiny, you could write smooth, then you move on to the next one. Scientists, are you with me? Yes. Okay, let's do this. We're going to pass these rocks out and our worksheets. Okay, so I'm going to have you two work pair, you two work pair. Can I have you what am I going to have you two do?
You guys didn't go to the bottom.
About where I'm going to have you guys for a second. Okay.
We don't have a worksheet. No, it's more like one side share and the other side. No, it's more like this row will show one side. I noticed some scientists are already recording observations. You're that much closer to your experiment.
You have about 1 more minute to finish up your observations. Write them on down. We're gonna have a minute for experiments in a second. But you've made a good observation now. Have a seat, write it down. Okay? Very good. Very good. All right, scientists, 20 seconds.
Don't smell
Okay, scientists, I would like all rocks back in the box with your rock close case. Your rock squeeze closed. In 5, 4, 3, 2, 1.
There never was any.
All right, you can have all attention up here. Scientists, I am noticing that you guys are doing some fabulous observations out there. Very focused, very interested. I love seeing that curiosity. So going back to our scientific method, did you guys make your observations?
Yes.
Yeah. Did you have some questions come into your head like, why is this one like that? What kind of rock is this? I wonder how this rock was made or what it's made of, right? Okay, so we had these questions come into our head. We are now ready to formulate our hypothesis, right, or hypotheses, because we're going to formulate more than one, and I have a little sheet here that's going to help you do it. Now what we're going to do is we're going to investigate the special properties of these rocks by first making a hypothesis, and then we're going to test our hypothesis using materials provided. So let's walk through the sheet, because what you're going to do is you have to formulate your hypothesis, number one, before you do your experiment. So let's walk through it together. The first question is, or the first hypothesis is, I think rock blank. There's a little blank space there. What do you think you're going to do in that blank space? Yeah.
Put a number.
You're going to put a number, right, that corresponds to which rock you're hypothesizing about. Okay. I think rock number blank will float because blank. So scientists, thinking forward to our experiment, if we're going to test that something floats, what are we probably going to use? Water. Okay. I think rock number blank will allow light to shine through because, what do you think we're going to use to see if light can shine through?
Flashlight.
We're going to use a flashlight. I think rock blank is naturally magnetic because blank. Some of you already know this one. Now, can I remind you, when we formulate our hypotheses, it is not a time to experiment on a rock. It is a time to look at your observations and make some educated guesses. Then we'll get to the experiment, okay? We also have some other tools we're going to use to test the magnetism of a rock. The next hypothesis is I think rock blank will leave a brownish red streak on the streak plate because a streak plate is just a rough surface. So a rough surface would be something that you could scrape a rock on and see if it'll leave a mark, okay? And then finally, I think rock blank can be scratched with a penny because blank. So you have to think to those observations. Use your observation sheet if you'd like. You can open those rocks back up. We're going to pass out your hypothesis sheets. I see sometimes scientists already writing down their hypotheses.
What number is that?
Oh, dude, number 2.
Okay, so I want to see some hypotheses being written down here. Give me some guesses.
I think I'm going to be where do we get the water? Oh my gosh, it's so cool. Because it has air. I think this is going to be the one
Well, it's obviously this light. Also, 80 years ago. You can't see these. I lost it. Yeah.
All right, scientists. Step one so you can hear my voice. I noticed that you guys are working hard. You're making some great observations. Make sure you're recording your hypotheses because the quicker we get through the sheet, that's when you get your hands on the materials to do the actual experiment. Okay? So try to blow through this as quickly as you can so we have lots of time for the experiment. You can sketch one of the rocks on the back of your hypothesis sheet if you'd like. Alright, scientists, I'm going to ask you to finish up in 5, 4, 2, and 1. Okay, folks. We have all eyes up here. Perfect. Saw some really great hypotheses written down on your sheets. That was very, very wonderful to watch your scientific minds in action. Now that you want to see the materials you're going to work with. Okay, so going back to that first question, I think rock number blank will float. You have a little cup of water. Now, question to you guys, how many rocks do you write down on each question? Just one. So if you guessed that, let's say rock number 3 floats, which rock goes in the cup?
Number 3.
It's only the rock that you guessed goes in the water cup, okay? Now I want each person to be able to do this experiment, so that means multiple people in your group might have different guesses, or maybe you both want to try it even if you guess the same rock, that's totally fine. But I want you to put it in there, see if it floats really quickly, and then take it out, okay? You'll also have a paper towel to dry your rock off, okay? And then we're probably going to take that water pretty quickly after you test it because otherwise it tends to get spilled sometimes. Now, next up, I think rock blank will allow light to shine through. flake is naturally magnetic. Now, some of you have already done some tests and found that some of our rocks are magnetic, but I would also encourage you to try it with the paper clips that are provided, because you may not know that paper clips are magnetic. So the rock will magnetize to the paper clip. What else do we have? What's up next? Oh, I think rock blank will leave a brownish red streak on a streak plate. The little plates that come in your kits are also streak plates. So do a little draw, like once or twice on there, to see if the rock that you think will leave a streak leaves a streak. And then finally, I think rock blank can be scratched with a penny. I'll give you a little penny to try that out. Are you guys ready?
Yeah.
We can't let you keep the pennies because we need them for the next class. Okay, thumbs up if you're ready. Are you ready to test your little rocks? With the paper towel. Yeah, and actually we'll go along with those. I don't know if we got those.
I see you secretly taking pictures.
Yeah. Secretly, I'm photobombing.
See, look. I bet you're good.
Focus on your rocks. Focus on your rocks.
It's guest speaker, guest speaker.
Clap twice so you can hear my voice. Thumbs up if you've completed your experiments. Okay. We're going to come along and we're going to start gathering up your supplies, and then I want to hear about your conclusion. Okay? All right, so go ahead and make sure your rocks get back in the order that they came in their kits. Make sure all of your materials materials go back on your scratch plate so we can easily pick them up.
That's slow. That's so slow.
Can you walk back to some
worked very well. Wait, are we getting graded on this one? I know.
Mr. Anderson, just taking a video.
Alright, please clap twice so you can hear my voice. I'm going to make sure I have everybody's attention. I'm waiting for a couple people in the very back. Ladies in the very back. Okay, so I'm very interested in what your conclusion was. Let me hear some conclusions. What did you guys find out? You might want to share some conclusions, or you might want to share some knowledge. Yeah.
I learned that number 5 did float.
It floated, right? That, my friends, is pumice stone. You may have seen pumice stone like in the nail polish section, Fred Meyer's or something, or like the foot care section, because people use pumice stones to actually grind off their calluses sometimes. But it is a natural stone that comes from volcanoes. When Mount St. Helens erupted in 1980, pumice shot out of the volcano and actually went into the Columbia River, and you could see huge chunks of it floating down the Columbia River. Why does it float? What are your theories? What do you think?
It's kind of like really light.
It's light, absolutely. Why is it so light? Something to do with the way that it's formed. What do you think?
It's kind of like a sponge.
Kind of like a sponge. Sponges have lots of what in them?
Holes.
Holes. And what do holes fill up with?
Water.
Well, first they fill up with air. Now, your cool thing about pumice stones, if we would leave them in that water for long enough, it would actually eventually, small pumice stones like that will actually eventually fill with water, and they'll sink. eventually, once those air bubbles fill with water. Cool stuff. What other conclusions? What other knowledge, guys? Yeah.
Rock number 3 failed to leave a red scratch on the plate because it left a black scratch instead.
So yours left a black scratch, but it still scratched the plate. That is
Yeah, it
very
still scratched the
interesting. That's very interesting, scientists. Yeah.
It failed. It has to leave a red one.
Rock number 4, the light shining on us.
Did anybody find that some of their hypotheses were incorrect? Anybody find that some of their hypotheses were incorrect? That happens to me all the time when I do science experiments. Another thing that I love about science, is it a problem if you get your hypotheses wrong? No, in fact, can you learn even more sometimes by getting a hypothesis wrong? Another thing I love about science, right? You can be wrong and in a way you're still right because you're still gaining knowledge. Very good. You guys, it was so nice to meet you. So fun to come to your classroom. We'll see you again on Thursday, March 31st. We can't wait. Okay? Have a great day. Thank you.
Oh, thank you. We need to give them a cheer. Okay, let's do a couple. This is the Elvis cheer. Ready?
Thank you. Thank you very much.
Okay, and then I was teaching these girls the Harry Potter one I just learned yesterday. So you hold your wand and you go. That was magical. Okay, ready? That was magical. Okay, very good. Make sure your names are on your papers and we'll bring them up here into. Let's just put them in this one right there. Knew it. Thank you. Thank you. Science.